Here now we can see the preparation of methane, ethane. It is for the alkane. We can see the preparation of alkane. Alkane, the general formula is CnH2n plus 2. For methane, the other name for the methane, greenhouse gas, natural gas, biogas. So I told you now we can see the laboratory preparation of alkane. You can see the apparatus setup. This is apparatus setup. Okay. The reactant, whatever we are using is sodium acetate. We are going to have take sodium acetate. The formula for sodium acetate it is CH3COONA. CH3COONA is the formula for sodium acetate. And then a UPAC name is sodium ethanoate because you are having two carbonate. Okay. So this is a reactant, sodium acetate or sodium propionate. Now you can see that sodium acetate you will be having the two carbon atom. So I told you it is ethanoate. Two carbon atom is you have to use the root word ethane, so sodium ethanoate. Now you can see this one sodium propanoate. One, two, three. So sodium propanoate. The common name is it is sodium propionate. So the reactant we are going to use for the preparation of methane and ethane, they are sodium acetate and sodium propionate. A UPAC name for sodium propionate is sodium propanoate. A UPAC name of sodium acetate is sodium ethanoate. These are the reactant. And here one more reactant also we are going to use, that is soda lime. Soda lime is nothing but the mixture of sodium hydroxide and calcium oxide. The reason why we are taken this as a mixture because soda lime is preferred since sodium hydroxide is a deliquescent substance. Sodium hydroxide is a deliquescent substance means you will be knowing that deliquescent means absorbs the moisture and it will be converted into the saturated solution. CHCCOONA plus NaOH. In this case, if it is going to react and you can just see this one, you have to heat this one. First you have to take this one, that is sodium acetate and then soda lime and then heat the mixture. If you're heating the mixture, the methane gas is collected. Now you can see the methane gas is collected here. So it displaces the water down and it is collected by downward displacement of water. Here, this otherwise it is also known as decarboxylation because see here Na2CO3. Carbon dioxide is eliminated as a carbonate. So it's also known as a decarboxylation. Now we can move on to the preparation of ethane. Now you see here CH2 and then CONA plus NaOH. Here, if you are going to take this one, see here it will be Na will combine with Na and it will come COO3. So you can remove this Na2CO3. If Na2CO3 is removed means it is decarboxylation. Now only I told you that carbon dioxide is removed as a carbonate. So you will be having the ethane. You can get the ethane. See, the reason is CH3, CH2 and then this hydrogen will combine to form C2H6. Again C2H6 you will be collected, it is collected by the downward displacement of water. So this is decarboxylation. The reactant used is soda lime. Soda lime is the mixture of sodium hydroxide and calcium oxide. We are using the mixture soda lime because sodium hydroxide is a deliquescent substance. Deliquescent substance means it will be converting into the saturated solution. So these are the information you have to know, and you have to know the name of this one also, sodium acetate, sodium propionate. Now another two general method is also there, that is from alkyl halide. That is alkyl halide, this is alkyl halide, methyl iodide and ethyl bromide. methyl iodide and ethyl bromide, you can prepare the methane and ethane respectively. Methyl iodide or ethyl bromide. Okay, ethyl bromide uh, will react with the reagent. What the reagent, you have to add a zinc and copper couple. Okay, you have to take zinc and copper couple in alcohol. So this one only will evolve the nascent hydrogen. It will be reduced. It will be reduced. The alkyl halide is reduced with the nascent hydrogen. See here. Here it is 2H. That means one H will be there and another H will be there, isn't it? It will be converted into CH3. This hydrogen will combine with this CH3 to form CH4. The remaining you are having HA, so it will be removed. So you can prepare the methane from the alkyl halide, that is nothing but methyl iodide. Methyl iodide or ethyl bromide. Methyl iodide will react with the reagent zinc copper couple in alcohol, will give us a nascent hydrogen. If it evolves a nascent hydrogen, it will combine with methyl iodide to form methane. Methane, and now you can see here this is a reaction. In this case, C2H5Br, as I told you, 2H means the same thing. If you are going to have the reagent zinc copper couple in alcohol, you'll get the nascent hydrogen. So here hydrogen and hydrogen, one H will be removed as HBr. Okay, so you can have HBr. And another C2H5 and then H will combine to form C2H6. So this is another method of preparation. One method of preparation is you can prepare the from the sodium derivative, that is nothing but sodium acetate and then sodium propionate. Okay, it is soda lime. Then the next method of the preparation is you can prepare the methane from methyl iodide, that is from the alkyl halide, and you have to know the reagent also. The reagent used here is zinc copper couple in alcohol, for the ethane also. And if you're going to have this one only, it will evolve the nascent hydrogen. So with this you can prepare the methane and ethane respectively. So that's the preparation of methane. Now we'll move on to the properties. This properties, you have to know the substitution reaction. Of course you have to know the oxidation also. Now first we will see the substitution reaction. In this case, the substitution reaction, now we can see this one, that is methane. Okay, so let me write methane. And the important thing you have to know that the condition is diffuse sunlight or ultraviolet light, or the temperature is 400 degrees Celsius. See, first let me take methane. The methane is CH4, and then this chlorine will combine, isn't it? Chlorine combine means there is a substitution reaction. One of the hydrogen atom is substituted with the chlorine atom. So let me write this one as CH3 and then H, here Cl and Cl. So what will happen? This HCl will remove. So you can see HCl, CH3Cl. That is nothing but monochloromethane or methyl chloride. You can see here CH4 plus Cl2, one hydrogen and Cl will combine to remove as HCl, and then one of the hydrogen atom is substituted with the chlorine, so CH3Cl, monochloromethane, methyl chloride. And if you're going to take CH3Cl, the monochloromethane, again you just pass the excess chlorine. If you're passing the excess chlorine, here again HCl will be removed, isn't it? So HCl will be removed. If HCl will be removed means you will be having CH2Cl2. And then if you're going to have this chlorine, so this one of the hydrogen atom will be replaced with chlorine, so it will become CHCl3. That is nothing but trichloromethane or chloroform. Now again you have to take CHCl3. Now if you are going to pass the chlorine here, this hydrogen atom is substituted with one chlorine atom to become CCl4, that is tetrachloromethane, and then you will be having the HCl. So this is a substitution reaction. Similarly, ethane, when chlorine gas is passed into the diffuse sunlight or UV light, in the presence of UV light, one of the hydrogen atom will replace with the chlorine atom to form monochloroethane, and hydrogen chloride is liberated. And here, if you're going to take this one of the hydrogen atom is substituted. So if you're going to substitute one of the hydrogen atom, it becomes C2H4. Then again chlorine will be added. So it is becomes Cl2. You have to remove one hydrogen, add one chlorine. Say remove one hydrogen and add one chlorine. So see here, remove one hydrogen, it becomes C2H3. Then add one chlorine, remove one hydrogen, add one chlorine, remove one hydrogen and add one chlorine. So it becomes C2HCl5. Remove one hydrogen, so add one chlorine, becomes C2Cl6. This is nothing but monochloroethane, then dichloroethane, and then trichloroethane, tetrachloroethane, pentachloroethane, then hexachloroethane. So in this case, if you're going to see the substitution reaction, one of the easiest way also you can write, we write for methane. So the first one you have to write CH4. Okay, you are going to pass the chlorine, isn't it? If you are going to pass the chlorine, let me write Cl2. Cl2, 1 H and 1 Cl will be minus. So what you have to do? Minus 1 hydrogen, add 1 chlorine. So minus 1 hydrogen means it becomes CH3. Add 1 chlorine. So it become monochloromethane. And then the next one, again add the past chlorine minus HCl. So I told you minus 1 hydrogen. So it becomes CH2 and add 1 chlorine. Already the Cl is there, so you have to write Cl2. There's nothing but dichloromethane or else methylene dichloride. The same thing if you're going to pass the chlorine, minus 1 hydrogen becomes CH, add 1 chlorine, Cl3. So it is trichloromethane or chloroform. Similarly, minus 1 hydrogen, add 1 chlorine, it is tetrachloromethane. Now I told you that you will be having the oxidation also. That is complete oxidation and then incomplete oxidation. Complete oxidation, first we will see the methane. Methane with oxygen. Oxidation is, you will be knowing that addition of oxygen. So add oxygen. We are adding the oxygen, the excess oxygen, or this is known as oxidation reaction, complete oxidation or combustion reaction. It will give carbon dioxide and water. So only all the alkenes, they are act as a fuel. Okay. So this is the equation. If you want to balance the equation, here it is 2O2 and here it is 2H2. Now let me take ethane. The ethane formula is C2H6. I told you this complete oxidation or combustion with the addition of oxygen. So add the oxygen. Again the products you will be getting carbon dioxide and water. Okay. Carbon dioxide and water. Now you have to balance the equation. If you balance the equation, it become 2 molecules of ethane combined with the 7 molecules of oxygen to form 4 molecules of carbon dioxide and then 6 molecules of water. Now you have to know